In this video, we'll look at what we need to do when we compare floats in our programs, and in particular, what we need to do when testing functions that return floats. We've seen that comparing floats for equality can give us surprising results. Now let's look at some ways we can compare floats while accounting for this imprecision. One way we can do this is by explicitly writing our code to consider two floats as equal if they are close enough or within some threshold. We can do this using the built-in function abs when we find the absolute value of the difference between the two values and check that this absolute difference is less than some fairly small number. In CSC 108, we'll use 10 to the power of negative 6, or 0.000001 as our threshold. For an example, let's revisit the while loop from the previous video, and this time use abs to determine if the counter is close enough to 1. This time, we'll use abs, and we'll find the difference between counter and 1. We want to continue while they're not equal, so we'll say while that difference is greater than our threshold. This time, we still see the imprecision in what we printed, but the loop only executes 10 times. Now, let's look at how we will write test cases for a function that returns floats. Here, we have a function called getAverageSongLength. It's not important at this point what the function does, but the notable thing for us is that it returns a float. I have some PyTest test cases already written for this function. Rather than using direct comparison of floats, which we know can give us incorrect results, or using abs, this code instead uses a new PyTest function. This function is called pytest.approx. We will use this function to write test cases for functions that return floats. Let's look at how these test cases are formatted and the syntax for using pytest.approx. Our test cases are written in a very similar way as we would test any other function. The difference is rather than asserting that actual and expected are equal using only the double equals sign, we assert that actual is equal to pytest.approx with the argument expected. The key thing you need to know here is that this allows us to use existing PyTest functionality that will check for the actual value on the left-hand side of the equality operator to be within some threshold of the expected value, which is the argument to pytest.approx on the right-hand side of the equality operator. We could also have used the absolute difference approach in our test cases. However, using the pytest.approx function makes our code easier to read and gives us fewer opportunities to make mistakes.